If you are building a home studio or trying to soundproof a room, you need to know exactly how sound behaves in your physical space. Your first instinct is likely to reach for a tool already in your pocket, your smartphone. Today, we are going to configure the Keuwlsoft SPL app, decode its advanced visual displays, and run a full calibration matrix to get the most accurate acoustic readings possible out of your device. Before opening the app, we have to recognize the limits of our hardware. A sound level meter, like the B&K Type 2236 on the left, uses a slender neck to move the microphone capsule away from the body to eliminate casing diffraction. Your flat rectangular smartphone acts as a reflector, generating high-frequency diffraction right at the source. Consumer-grade microphone chips also struggle with extreme frequencies, showing heavy roll-offs in the bass register. Plus, cheaper hardware might saturate and max out after just 20 decibels of dynamic range. Because of this physical reality, acoustics professionals legally classify mobile app readings strictly as for indication only. While you cannot use your phone for a certified commercial noise survey, once we properly calibrate the software, it becomes a highly capable tool for measuring relative acoustic improvements in your personal studio. When you launch the app, the interface is split into two halves. At the top is the analog dial view, which automatically rotates to match your device's orientation. As sound enters the microphone, the main black needle tracks the current level. You will also see two persistent blue needles on the dial. These lock into place to hold the absolute minimum and maximum sound pressure levels recorded during your active session. Immediately below the dial is the digital status field. This text block gives you high-precision numerical readouts for your current, minimum, and maximum levels, as well as an integrated average and a running digital timer showing exactly how long that averaging session has been active. Along the middle of the screen are your primary control buttons. You can tap pause at any time to temporarily freeze the incoming microphone data, and press clear to instantly flush the history buffers and restart your minimum, maximum, and average logs. The most powerful feature in this row is the REL, or relative, button. Tapping this captures your current integrated average sound level and locks it in as a baseline offset of exactly 0.0 decibels. Any new sounds in the room are now measured directly against this anchor point. A positive decibel value means the new sound is louder than your reference, while a negative value indicates a quieter environment. This top half of the dashboard gives you the ability to monitor absolute volume ceilings, while also performing instantaneous, precise comparisons as you adjust the acoustic treatment in your environment. The bottom half of the interface changes based on the 4 digital mode buttons. Tapping the graph button replaces the lower screen with a real-time, scrolling time series wave graph. To examine a specific volume spike, you can manually scale the y-axis by pinching and panning your fingers directly on the graph display. This diagram illustrates the spectrum view. The app uses a fast Fourier transform, taking a 16,384-point sample of the raw waveform, dividing its energy into logarithmically spaced fractional bands. The real-time analyzer displays these bands, marking each octave's highest peak with a solid blue bar. To adjust how these frequencies are processed, tap the Settings button. Here you will find the primary parameters for the app, including the crucial audio weighting options. For environmental noise testing, you should select A weighting. This applies a filter to the high and low frequencies, shaping the incoming microphone data to closely mimic the natural sensitivity of the human ear. By combining A weighting with the fractional bands of the spectrum view, you can visually pinpoint exactly which frequencies are causing problems in a room, rather than just reacting to the raw overall volume level. Our final configuration step is to open the Cal, or calibration, menu. Because smartphone microphones vary wildly in sensitivity, this interface allows us to align our app's readings with a professional hardware reference meter. To take a calibration measurement, tap one of the measurement boxes. The software allows you to define the exact duration of the listen window, and you can program a delayed start time so you can step away and avoid interfering with the sound field. If you set a delay, a red countdown timer appears first to indicate the late period. Once the measurement actually begins, a blue progress ring tracks the active listening window. When the active listening phase finishes, check the true decibel reading on your physical reference meter and type that exact number into the app's Enter Actual box. Depending on how many reference points you enter, the software applies a different corrective math formula. A single point applies a flat offset across all volume levels. 2 points create a linear fit to balance the quiet and loud extremes. Entering 3 points calculates a complex polynomial fit, which corrects for the physical compression that happens inside the capsule at high sound pressure levels. Your smartphone's physical capsule will always have limitations, but building a detailed 3-point software calibration profile aggressively narrows the accuracy gap between a mass-produced consumer device and professional acoustic hardware. Your application is now A-weighted, digitally calibrated, and configured to capture detailed frequency responses across the audio spectrum. To test your setup, sit in a quiet workspace and tap the REL button to lock in your 0.0 decibel baseline. Then, introduce a new noise source to the space, like turning on your air conditioning unit. Watch the digital status field. The new positive decibel value tells you the exact amount of noise that specific fan added to your resting environment. You now have a pocket-sized, objective digital dashboard ready to quantify acoustic issues and verify exactly how well your future soundproofing treatments perform.